Welcome to session 3 in lesson 1. In this session, you will learn the basic principles of multi-factor APT models and the Fama-French 3-factor model. The learning goals for session 1.3 are: you should be able to apply the concept of multi-factor models of risk and return. You know the concept of the multi-factor arbitrage pricing theory model, and students should be able to explain and use the Fama-French 3-factor model. The multi-factor APT. In the previous session, we have assumed so far that only one systematic factor affects stock returns. This simplifying assumption is in fact too simplistic. We have notes that we can think of several factors driven by the business cycle that might affect stock returns: interest rate fluctuations, inflation rates, and so on. Presumably, exposure to any of these factors will affect a stock's risk and hence its expected return. Accordingly, we can generalize the single-factor model to a two-factor model. The two-factor or multi-factor APT is shown in the formula below. Factor 1 was the departure of GDP growth from expectations, and factor 2 was the unanticipated change in interest rates. Each factor has zero expected value because each measures the surprise in the systematic variable rather than the level of the variable. Similarly, the firm-specific component of unexpected return EI has also zero expected value. Extending such a two-factor model to any number of factors is straightforward. The benchmark portfolio in the arbitrage pricing theory are factor portfolios, which are well-diversified portfolios constructed to have a beta of 1 on one of the factors and a beta of 0 on any other factor. We can think of each factor portfolio as tracking portfolio. That is, the returns on such a portfolio track the evolution of one particular source of macroeconomic risk, but are uncorrelated with other sources of risk. It is possible to form such factor portfolios because we have a large number of securities to choose from and a relatively small number of factors. The multi-factor security market line example. Suppose that the two factor portfolios 1 and 2 have expected returns of 10% and 12% respectively, and a risk-free rate of 4%. The risk premium on factor portfolio 1 and 2 are computed as follows. It's simply its expected return minus the risk-free rate equal to 10% minus 4%, resulting in a premium of 6%. For portfolio 2, it results in 12% minus 4% equal to a premium of 8%. Now consider a well-diversified portfolio A with a beta of A equal to 0.5 and a beta of A2 equal to 0.75. The multi-factor APT states that the overall risk premium on this portfolio must equal the sum of the risk premiums required as a compensation for each source of systematic risk. The total risk premium on the portfolio and the expected return on the portfolio can be computed as follows, using the general formula, which is simply the risk-free rate plus the total risk premium, whereas the expected error terms are equal to 0. This means 0.5 times the 6% previously calculated plus the 0.75 times the 8% premium of P2 equal 9% total risk premium. Adding the 4% risk-free rate totals 13%. To generalize the previous example, note that the factor exposures of any portfolio P are given by its betas, beta of P1 and beta of P2. A competing portfolio Q can be formed by investing in factor portfolios with the following weights: beta P1 in the first factor portfolio, beta P2 in the second factor portfolio, and as a result, the remaining proportion of T-bills is simply 1 minus beta P1 minus beta P2. By constructing portfolio Q, will have betas equal to those of portfolio P and expected returns calculated by the following formula known as the two-factor SML. If you see from the first to the second formula, we simply rewrite that we get the risk-free rates plus the beta 1 times the premium of portfolio 1 plus beta 2 times the premium of portfolio 2. Mispricing and arbitrage example. Suppose that the expected return on portfolio A from the previous example were 12% rather than the previously calculated 13%. This return would give us an arbitrage opportunity. From the factor portfolios with the same betas as portfolio A, requiring weights of 0.5 on the first factor portfolio, 0.75 on the second factor, and a weight of minus 0.25 on the risk-free asset, so that all three factors sum up to 1. This portfolio has exactly the same factor betas as portfolio A. The weight of minus 0.25 on risk-free T-bills does not affect the sensitivity to either factor. If you invest $1 in portfolio Q and sell $1 in portfolio A, your net investment is 0, but your expected dollar profit is positive. Compute your expected dollar profit will actually result in $1 times the 13% minus $1 times the 12% equal to 1 cent per dollar. So you have a long position on the higher expected return, a short position on the lower expected return, resulting in an arbitrage free profit of 1 cent per dollar invested. Continuing on the previous example, we realize that the net position is riskless. Your exposure to each risk factor cancels out because you are long $1 in portfolio Q and short $1 in portfolio A, and both of these well-diversified portfolios have exactly the same factor betas. Therefore, if portfolio A's expected return differs from that of portfolio Q's, you can earn positive risk-free profits on 0 net investment positions. This is an arbitrage opportunity. Before we discuss the Fama-French three-factor model, we have previously seen that the arbitrage pricing theory shows us how multiple risk factors can result in a multi-factor security market line. But how can we identify the most likely sources of systematic risk? One approach is to use firm characteristics that seem on empirical grounds to proxy for exposure to systematic risk. The factors chosen are variables that on past evidence have predicted average returns well and therefore may be capturing risk premiums. This approach is the Fama and French three-factor model defined by the following formula. Now you can see that the first part is equal to the CAPM, the risk-free rate plus a beta times the market risk premium. The second term is actually a factor, which is a size factor small to large companies, and the second factor is value versus growth stocks. Notice that in this model, the market index does play a role and is expected to capture systematic risk originating from macroeconomic factors. The other two factors are firm size, measured by the market capitalization, and book-to-market ratio. Let's have an example using the Fama French three-factor model. Now, as we have previously seen, using this formula and given the following input data, with a risk-free rate of 3%, a market beta of 1.2 and a market premium of 5%, adding as well the size factor beta of 0.12 and the SMB equal to 2.2%, and the last addition is the value growth factor beta equals 0.34 and HML equal 3.8%. The result is 10.56%. The multi-factor CAPM and the APT. A multi-factor arbitrage pricing theory generalized the single-factor mode to accommodate several sources of systematic risk. The multi-dimensional security market line predicts that exposure to each risk factor contributes to the security's total risk premium by an amount equal to the factor beta times the risk premium of the factor portfolio that tracks that source of risk. The multi-factor extension of the single-factor CAPM is the ICAPM. It suggests that priced extra market risk factors will be the ones that lead to significant hedging demand by a substantial fraction of investors. We are at the end of session 1.3. After having carefully studied the slides and relevant chapters in the book, please start with the review questions.